Now you know what an IP address is. What's the difference between a public IP address and a private IP address? To recap, a public IP address is an IP address that's accessible on the internet. It's publicly available, anybody can access it. A private IP address, on the other hand, is not accessible directly on the internet. So if you're connected to your home network, you're very likely to have private IP addresses on your laptop, on your desktop, and on your mobile. At this point in time, you might be right to wonder, how are you able to access the internet if you're using a private IP address? How is it possible that your machine with a private IP address is able to communicate with a machine on the internet with a public IP address? This is where NATing comes in place, and its sole purpose is to translate data from private IP addresses to public IP addresses and the other way around. This is an example setup we're going to be looking at, so we understand how NATing works. On the left-hand side, we have two machines. Let's assume you're at home, you have two laptops connected to your wireless router. So the first one has the IP address of 192.168.1.111, and the second one is 192.168.1.112. These two laptops at home have private IP addresses. Both these machines are connected to your wireless router. If these two machines need to talk to each other, it's very straightforward and simple. All they have to do is redirect the traffic through the router and talk to each other. As a matter of fact, the router doesn't need to even be there. If you plug in these two machines directly through a network cable, they would still be able to talk to each other. So if you right now go grab a network cable, plug it into one laptop and then plug it in another laptop, you just created a network and these two laptops can talk to each other, provided that they have IP addresses within the same range, such as the ones in our example. The wireless router though makes it much easier for this to happen. So instead of plugging cables all across your living room, all you have to do is connect your devices, your laptop, your desktop, your mobile, to the wireless router, and it just redirects the traffic wherever it needs to go. So the router in this case will see traffic coming from 192.168.1.112, and it will see that it is destined to 192.168.1.111, and all it does is that it redirects it from the source to the destination. The device in the middle, this represents your wireless router. You can see that on one hand, on the left hand side, you can see that there's an IP address of an interface of 192.168.1.1. So if you grab your wireless router right now, you're gonna see that there are different ports, different places where you can plug in a network cable. If you plug in a network cable on one of these ports, you will get assigned one IP address. If you plug in the network cable in another port, you get assigned another IP address, so on and so forth. So your router would actually have an IP address of its own, meaning that if the device at 192.168.1.112 wants to talk to the neighboring device of 192.168.1.111, the data will have to flow through the router at 192.168.1.1. So the path that the data will take is computer A, router interface, then computer B. This is networking in its simplest form. Two devices on the same network talking to each other. We're gonna be showing you a video, an animated video in a moment, so you get a better understanding of this. Now the question is, what happens if one of these two machines want to talk to a server on the internet with a public IP address? You might have noticed by now that the router has two interfaces with two different IP addresses. So on the left hand side it has the 192.168.1.1. On the right hand side it has the 20.30.40.50, and this is a public IP address. So for example, if the machine on the left hand side at 192.168.1.112 wants to talk to a public IP address, in our case 8.8.8.8, the traffic will go first to the internal interface of the router with the IP address of 192.168.1.1, and then the router will have the job of translating this in such a way that it will be understood and routed to a public IP address. So internally what will happen is the router will take the data from 192.168.1.1 port and translate it to the other port at 20.30.40.50. And at that point in time, the data will be attached to a public IP address, making it possible for other devices on the internet to see it and communicate with it. And when the data is being sent back from the internet, it will reach the public interface at 20.30.40.50. The router will take this data, translate it to an internal IP address, and then forward it on to the destination. Perhaps a video will make it easier to visualize this. Let's have a look. So in our first scenario, our internal computers want to talk to each other. Both computers are at home with private IP addresses. 192.168.1.112 wants to talk to 192.168.1.111, and all it has to do is send the data to the router that will in turn forward it to the other machine. What if our internal machine now wants to talk to a public machine? The data will go through the router to the first interface at 192.168.1.1, then to the second interface, which has a public IP, all the way out to the internet, and then the other way around coming back in. Let's verify this. Let's have a look at what path our data is actually taking. To do this, let's go back to the command prompt and type ipconfig. This will show our IP address, and it will show us also the default gateway. The default gateway will be the IP address of the router's interface that does the NATing for us. There's another command that we can use in Windows called traceroute. And what this command does is, as the name suggests, it traces the route that our traffic takes to reach a destination. What we're doing now is we're doing a traceroute to hackersacademy.com to see the path that our packets are following. And as you can see, the very first hop that our data takes is the 192.168.237.2 IP address. In this case, this is the IP address of my router, which confirms what we have been talking about. For my machine on my internal network to be able to talk to hackersacademy.com, which is a public domain, the data will have to flow from my machine to the router that does the NATing and then gets sent to the internet. So here is your mission for this section. Go ahead and do a traceroute from your machine to Google and identify the IP address of your gateway. There's a very good chance that if you're on a wireless network at home, this is going to be the IP address of your wireless router. See if you can access this IP address and what you can discover on it. And remember to always record your success.